Alright, the first one is arc cosine negative 1 over 2. So arc cosine you can use top half circle. Okay, that is quadrant 1 and quadrant 2. By following all, student take calculus. You know, negative 1 over 2 is negative, so the first quadrant all means everything is a positive, so this guy is gone. Has to be the second quadrant. Okay, in the second quadrant, cosine we need the x-coordinate, and you look at unit circle, second quadrant, x-coordinate is negative 1 over 2, that's a 2 pi over 3, so your answer is 2 pi over 3. Right, second one, tangent inverse square root of 3. Tangent inverse, you are allowed to use the right side of the circle. That's quadrant 1 in quadrant 4. Square root of 3 is positive. Okay, so all students take a calculus. The fourth quadrant will be cosine and secant only positive. Tangent is negative. That's how you know cannot be in the fourth quadrant. So your answer has to be in the first quadrant. And look at the first quadrant here. Okay, square root of 3, that is a pi over 3. So your answer is a pi over 3. Right, sine inverse. Again, sine inverse, you are allowed to use the right side of circle. That's quadrant 1, quadrant 4. Okay, and because you have a sine value, you're looking for a sine, what angle can give you this negative 1 over 2 from the right side of the circle. So if you look at the right side of the circle, okay, the y value is a negative 1 over 2, which is 11 pi over 6. 11 pi over 6 will look like this. Okay, that's 11 pi over 6. However, we are not allowed to go to the left side because our green zone is on the right side. So another way to describe this 11 pi over 6 will be negative pi over 6. Okay, so this is our answer. All right, number 4 will be composite inverse because you combine all of them together. When you solve a question like this, you want to solve it inside out. So you're going to solve this guy first. Cosine 2 pi over 3. Okay, you find the 2 pi over 3 on the unit circle. And you need cosine, which is the x-coordinate. That's negative 1 over 2. You replace this cosine 2 pi over 3 to negative 1 over 2. Okay, every time you have this inverse, this negative on top right corner, that's the inverse sign. Every time you have this inverse, your answer has to be restricted. Okay, so this will be right side of the circle, sine inverse. That's quadrant 1 and quadrant 4. Because you have a negative 1 over 2, so first quadrant is gone. Okay, so quadrant 4, you need a y-coordinate is negative 1 over 2. Look at your unit circle, 1, 2, 3, 4. In the quadrant 4, y-coordinate is negative 1 over 2. Again, it's 11 pi over 6. In 11 pi over 6, you just went to the left side, which is we cannot use. That's 11 pi over 6. Okay, another way to describe the same angle, which is negative pi over 6. Okay, that's our final answer for number 4. Number 5, again, we solve inside out. We solve this cosine negative pi over 6 first. And on the unit circle, this is a positive pi over 6. Negative pi over 6, you go to the opposite direction, which is this guy. Negative pi over 6 is 11 pi over 6. We need cosine negative pi over 6. Which is we need the x-coordinate, square root of 3 over 2. So you're going to replace this whole thing to cosine inverse square root of 3 over 2. Cosine inverse, you are allowed to use top half circle. That is quadrant 1 and quadrant 2. Okay, and square root of 3 over 2 is a positive, so second quadrant is gone. So you're looking for in the quadrant 1, and you want the x-coordinate is square root of 3 over 2. The quadrant 1, x-coordinate is square root of 3 over 2. The angle is pi over 6. So pi over 6 is your answer. Number 6, arctangent. We solve inside out. We need to solve arctangent first. Okay, equals 4 over 3, which is, this is the time you know, this is normal answer you can find it from unit circle, because the 4 over 3 is in the middle of nowhere. You have to draw your own circle here, own triangle. Arctangent, you are allowed to use the right side of the circle. That's quadrant 1 and quadrant 4. Okay, and 4 over 3 is a positive number, so quadrant 4 is gone. You know your angle, your triangle should be in the quadrant 1. So you're going to draw the triangle in the first quadrant. Tangent equals y over r. So you have 4 over 3. So your y will be, my bad, tangent is y over x. You have a 4 over 3. So your y has to be 4. Your x has to be 3. Okay. If you use the Pythagorean theorem, a squared plus b squared equals c squared, you can figure out this radius equals 5, which is 3, 4, 5 Pythagorean triple, however you want to solve. Okay. We need secant of this angle. Okay. And secant's best friend is a cosine. Cosine equals x over r. Secant is a reciprocal of a cosine, which is r over x. Our r value is 5, our x value is 3, so r over x equals 5 over 3, and you record your answer 5 over 3. All right, number 7, 3 Pythagorean identities. Number 1 will be cosine theta squared plus sine theta squared equals 1. Number 2, 1 plus cotangent theta squared equals cosecant theta squared. Number 3, 1 plus tangent theta squared equals secant theta squared. Okay. Number 8, reduce the term. Okay, so your job is to make sure you simplify it, make as short as possible. This is your question. The first thing you do is, I guess I'm going to copy this question one more time. You have a sine theta plus cotangent theta times cosine theta. Okay. Cotangent by the quotient rule can be changed to cosine over sine. So that will be the first thing I would like to do. Cosine theta over sine theta multiply with cosine theta. I normally give this guy over 1, just make it easier for myself to see. Okay, so far I did nothing except to change this guy to this guy. Okay, all right, so right now I cannot add them because they don't have a common denominator. So in order for me to add them together, I would like to make sure this guy has a sine theta as a denominator. So I will do sine theta multiply to the top and the bottom. Okay, the blue is what I just added. By doing so, the first piece I have is sine theta squared over sine theta. Second piece I have is cosine theta squared over sine theta. Because they have a common denominator, I can actually go ahead and add them together. You have sine theta squared plus cosine theta squared over sine theta. Which one? This one? Okay, because the cosine times the cosine is a cosine square. Is that okay? Yeah. So this numerator, by using Pythagorean identity here, is actually equals to 1. And therefore you have 1 over sine theta. Okay? 1 over sine theta is cosecant theta. That's the shortest way, simplest way we can simplify. So your final answer is cosecant theta. Okay, we use the quotient rule here. We find a common denominator here. We use the Pythagorean identity here, and then at the end we use the reciprocal identity. Okay, we pretty much use everything for this question. All right, next one. So step 1 I would like to do is use the quotient rule to change the cotangent square theta. So this left side will become sine theta squared multiplied with the cosine theta squared over sine theta squared. And all I did is to change this guy by quotient rule to this guy. Okay. Now number two, step two, I would like to sine theta squared is sine theta squared over 1. Okay, so I can actually go ahead to cancel this guy. And then all I have left is cosine theta squared and over 1. Okay. By Pythagorean identity, which is here, we have a cosine theta squared plus sine theta squared equals 1. So if I modify this guy, move this sine theta squared to the right side, I actually can have the additional 1 cosine theta squared equals 1 minus sine theta squared. Okay, I actually can create this guy. So I'm going to use 1 minus sine theta squared to replace this cosine theta squared. So I have 1 minus sine theta squared. Okay. Now from here, I can use difference between perfect square to expand this guy because 1 is 1 square. Oh, okay. We have a squared minus b squared. In algebra, we learned this. If you have a squared minus b squared, and that is a plus b times a minus b. Okay. So that's your a, that's your b. If you have a squared minus b squared, that is your a plus b times a minus b. Okay. And as you can see, this guy looks just like what they want us to prove. Okay, so that's your step 1, that's your step 2, that's your step 3. By using difference between perfect square, eventually step 4, you proved what you want to prove here. That's correct, you're right. We are going to prove everything, do everything you can on the left side to match the answer to the right side. We do formal proof and the test. Okay. All right. Number 2 is evaluate. 105